So I told you two, but here is the third one. Okay, this is the function, the natural log x e to the x squared. X e to the x squared is the argument of the natural log function. What we need to do here, we need to find the tangent, or the equation of the tangent. At x equals 1. All right, so since you're all educated, you know that in order to find the equation of a line, I need the slope and I need the point. Okay? We've done this before. So since I don't have a point, I need to find a y value. So the y value when x equals 1 is simply the natural log of 1 times e to the 1 squared, like so. Okay? So it's the natural log of e, which is 1. So the point is 1, 1. So we need a point. The point is xy equals 1, 1. Okay, so we took care of this business. The next is we need to find the tangent. Well, we know that the tangent, or the slope of the tangent, rather, is the derivative at this point. So the slope of the tangent will be y prime when x equals 1. Okay, so now we need to find the derivative of this function right there. So this will be, I'm looking at this function and I can see that, first of all, I know that there is a product here because you have x times e to the x squared. Well, you have a chain rule to begin with because this is natural log of a product. So I have a chain rule, but I have another chain rule with e to the x squared. So the procedure will require to A, apply the chain rule initially, B, apply the product rule, and then C, apply the chain rule one more time. Okay, so we need to go through this motion, and let's see, y prime. The first chain rule is the outside function, the natural log. So we have 1 over the argument. The argument is x e to the x squared. And now we need to multiply by the derivative of x e to the x squared. Okay, so here's the product rule. X times e to the x squared. The derivative of x is 1. So we have 1 times e to the x squared plus x times the derivative of e to the x squared. Well, the derivative of e to the x squared is e to the x squared times the derivative of x squared. And the derivative of x squared is 2x. Okay, so we have e to the x squared, which is the derivative of the outside function, which is e to the u. And then if u equal to x squared, then du dx is 2x. Okay, so, and that's it. Now we need to put everything together. So let's see. We have e to the x squared will be factored out both from the numerator and the denominator. But let's factor it out from the numerator. We have 1, and here we have 2x squared. All right? And we have also e to the x squared multiplying x. So after simplification, we end up having 1 plus 2x squared over x. So it's not too bad. Now we want to find out what happened with when x equals 1, and this will give us the slope of the tangent. Okay, so plug 1 and get 1 plus 2 times 1 squared over 1, and we get 3, the slope of the tangent. At this point, we have the slope and we have the point, 1, 1, so the equation of the tangent will be 1, the y value of the point, plus the slope, which is 3 times x minus 1. And it will be 3x minus 2. Okay. Again, this is one of those things that will be nice to put on the graph program. Graph the function, find the point 1, 1, and then plot the tangent to see that indeed the tangent touches the function at this point 1, 1.